This lesson puts a math slant on something you've probably learned in science, which is slope. And for math, we could talk about slope as a ratio, and remember our last unit was a ratio of two, comparing two different quantities. This is a ratio comparing the change in a vertical distance to the change in the horizontal distance. So in science class, most likely you learn that slope equals rise over run, which is true, and we're going to use that a lot too. Another way that we can look at this is slope equals the change, which is delta, the change in the vertical distance compared to the change, delta, in the horizontal distance. And other words that we use to describe slope, the most common word that you'll see is basically steepness. How steep is something? A line segment on a graph, a roof, a hill, they would all have what we compare a slope, and we compare it by saying how high is this hill going for however long it's going on a straight horizontal line. So the vertical distance in any kind of slope situation, the vertical distance, remembering vertical is a line that's up and down like this. So the vertical is my rise, horizontal is a distance that goes like this, and that becomes my run. So if anything talks about a vertical distance, that's talking about your rise. If it's mentioning a horizontal distance, we're talking about a run. So let's look at some simple questions that deal with this concept of slope. So question 1 is saying, calculate the slope of a line that has a rise of 12 centimeters for a run of 8 centimeters. Now there's something that we should point out here. Slope, like many things in math, does have a shorthand kind of notation for it. Slope is represented by the letter m. So you can write slope equals, or we could say m equals. They both mean the same thing. So I'm going to use m. I'm going to say slope is rise over run. That's the simple part. That's the comparison. That's the ratio of the two quantities. So our slope, if we read the question, it has a rise of 12. So rise is the numerator here. So rise of 12 and a run of 8. That's 12 eighths. That means whatever we're talking about, this line goes up 12 units for every 8 that it goes across. So we know also that we could put this into simplest form. Both of these are divisible by 4. So in simplest form, the slope of this line segment is 3 to 2. If we were looking at the line, we could say the line will go up 3 units, 1, 2, 3. For every 1, 2 it goes over. That is a slope of 3 halves. It goes up 3, but it runs 2. So example 2 now. The slope of a line is 7 to 20. What is the rise if the run is 100 meters? So we can start by saying, well, we know that slope is rise over run. And this question tells me that the slope is it rises 7 for every 20 it goes to the right. But the question's saying, well, what would the rise be if the run is 100 meters? So we could set up a proportion to talk about this. So we could say 7/20ths. If this is my rise, this is my run. We read the question carefully. It's saying, what is the rise? So that's my unknown. So I'd say the top thing is the thing I don't know. If my run is 100 meters. And we looked at this with proportions in our last lesson. There's two things we can do here. We could cross multiply and say that's 7 times 100 divided by 20. Or if you're good with fractions, we could also look and say, okay, how did I change this to get to 100? Well, that's multiplied by 5. So that means I have to multiply the top also by 5. So this tells me that I'm looking at a rise of 35. Or if we did this cross multiplication, and I'll prove it over on the calculator, we could say 7 multiplied by 100 divided by 20, and you could see we have a rise of 35 meters, over 100 meter run of this line. The last example, we're talking about this girl Justine. She's building a ramp in 2 different sections. So both have the same slope, it says. If one section rises 2 meters for every run of 6.5 meters, how much will the second part have to rise for the remaining run of 9.8 meters? So she's building it in 2 sections so she can haul it and put it where she needs to go. But what we do know, again, slope is rise over run. So we start there and we start to fill in the information we know. So she's building 2 parts of the section. One has a rise of 2 meters for a run of 6.5. So 2 meter rise for a run of 6.5 meters. So make sure you're putting it in the right spot. So that's the slope of this ramp. Rises 2 for every 6.5 it goes over. But then the question goes on and says, well, what would the rise have to be? So again, the rise is my question mark up here. We don't know the rise. If it needs a run of 9.8 meters. So we set up a proportion again to figure this out. One of the key things, and I kind of wrote over top of it here, one of the key things in this question is right here. She's building it in 2 sections, but they have the same slope. That's why I can say that these 2 slopes are equal. So now to solve this situation, I would cross multiply and say, well, my unknown rise is 2 times 9.8 divided by 6.5. So we can do that 2 times 9.8 divided by 6.5 on the calculator is roughly 3. So we'll say approximately, this is what this dot means, you need approximate rise of 3 meters. So the last part, she needs a 3 meter rise if she wants to keep that second section going at the same slope. So that's what slope is. Slope is just another fancy word for steepness of a line, or steepness in this case of a ramp. And we could use it as a ratio because it is comparing the change in vertical distance, the rise, to the change in horizontal distance, the run. And we can use it to make proportions and solve questions.